All right, good morning, good afternoon, welcome. We'll be getting started shortly. Welcome everyone, thank you for coming in. We'll be giving folks a few more minutes to come in before we get started. So you can sit back, relax, have some popcorn and some coffee, and we'll be leading this shortly. All right, I think we can get started. So I'll just say good morning, good afternoon. Welcome to today's special webinar. Thank you for joining us for part 2 of our KubeAcademy office hours. And this week we'll be covering managing applications. So without further ado, let's hand this off to Ryan.
Thanks, AJ. Hey everyone, nice to see folks again, especially when a lot of times, not in front of the live classroom as much as I used to be. So without ado here, let's get started. Okay, so as a reminder, as AJ said, this is part 2, and on KubeAcademy, we have learning paths. And one of the learning paths that we launched recently is the Kubernetes core concepts. And we split it up into 5 parts, each one a combination of lessons and labs. And for this, we have a one-on-one ratio. We have a lesson, lecture, and then we have lab. And last month, we did this first one, which was platform. And now we're on to part 2, which is we call managing applications. So we know about containers, we know about Kubernetes, and now we're going to say, okay, let's step a little bit further and see where we're at in regards to not just we got it running, but let's start to see the life cycle of managing an application and so on and so forth. And so hopefully you guys have already taken some of these lectures and everything. And I'm going to be focusing mostly on the lab part that tends to be fun, right? And I'll be demoing some of the labs, and that'll hopefully spark some questions as we go through it. We can ad hoc look at some things, etc. But I guess first, just to start things off, let's see where folks are in the world right now who have joined so far. So myself, I'm in Florida in the US. So it is quite hot here this week. We are almost 100 degrees, I believe. The AC sure is working down here quite a lot. San Francisco. Yep. Those microclimates there. Derek, I was born in Ohio, actually. So seems to be a heat wave in the country in general right now. Dallas, definitely hot. Atlanta, hot Atlanta, yes. That section of the country gets very humid right now this time of year. I'm going to go ahead and launch this lab and get it going while we banter. Okay. Well, thank you all for joining, especially if it's an awkward time for you, but it looks like we got quite a few East Coast and Central time here. Okay, so I'm going to launch lab here. And what it's going to do is it's also going to, we're going to fast forward it. And I'll launch the other one too, just in case we want to go into it later on. Okay. All right. Now, if you recall in these labs, basically what we do is it's meant that you could sit down and do them all at once. So to speed things up, what we do is we sort of replay what we would have done in the last labs. And that is we had this Go web app container. It's a web application written in Golang, and we had a MySQL backend. And we created Docker containers for it. And then we wrote the YAML files to deploy it into Kubernetes and got it working with a service. So we ended up writing, if you recall, there were 4 YAML files, a service and deployment for each. And so this is basically just doing that for us. Once it's done here, the YAMLs have been pushed in and we will sort of see everything working. Okay, so if I do a Docker images, for example, I see the ones from 35 seconds ago, the Go web app and the Go web app MySQL. And then if we do a kubectl git pods, we have the thing running. And if we describe the service of Go web app, right? We essentially see that, yes, 2 endpoints are in there. It's healthy. We are good. Okay. So now we can start with the lab part. We know this is up and running. So let's take a look and see what we're going to do. Yes, we will be recording. This is being recorded and we'll have it afterwards. And AJ can provide more info on that. So what we're going to try to simulate now is, hey, we got the application out there, but applications aren't static, right? We have new versions of them, enhancements, we got to fix things and so on and so forth. So to make things easy here, what we're going to do is we are going to make a new version of the Go web app. So all we're going to do is we're going to change the word Tanzu that shows up in the title of the web page to say Tanzu improved, to sort of simulate something here. And we just do some commands here to make it easy for us. We do the build and then we push it. So now if we do a Docker images, we see a new one from 8 seconds ago, which is the Go web app, but it's v1.1 instead of the 1.10 that we had before. Let's do a little bit better. There we go. Okay. So now that we have this new one, we can test pausing and doing rollouts. So if we look, where are we at here? Okay, let's go into where this thing's at. Let's go look at one of, here we are. And right now we're referencing v1. So let's go ahead and update, just simulate like what we would do and make this we're ready to roll out the new version. Okay. So what we can do is Kubernetes goes pretty fast. So what we're going to do is we're going to deploy it, wait a second, so sleep a second, and then we're going to pause the thing. If you recall, with kubectl deployment, there's a thing called rollout, right? And rollout, we can do a pause, a restart, resume, status, etc. So if I do kubectl rollout history, okay, well, we got to say something. Double tab might help us. Go web app. We don't have an active rollout going on, right? Now, what we're going to see is once we start it here, we're going to see this. So let's go ahead and go. Okay, it applied, waited a second, and then we paused it. So my first thing whenever I sort of want to grok the universe is say, git pods. All right. So notice we have a new pod in a running state, right? Okay. And if we look at this, it's the new version, right? So if we just kubectl describe pods, and we could even grep for Go, we can grep for V and then V1, right? So we see some of the V1s and some of the V11s. If you've ever wondered this name, the beginning part, go web app, comes from what the name in the YAML file is. Then you always have this middle ID. And it's the same between these two. Then you have the unique IDs for each pod. This middle ID is not by accident. That is actually the definition like of the replica set representing all the pods that are the same. So since this is the new one, this ID is of the new replica set, right? Right. Notice they actually match here, right? Here's the one with V1, and here's the one with the V11. Okay. So we're going to see this. It's paused. I'm basically showing what we did in lab instructions here. Now we can describe the deployment. Okay. If we do that, notice it scaled up the history here. This was when I originally put it in that line. And then we went to 108 seconds ago, about 2 minutes ago, it made the new replica set and it scaled it up to 1. So we sort of see that history there, right? And notice that our status here, we are currently deployment paused. Okay. So we can resume this thing. And, you know, we're dealing with small numbers here right now, right? If this were something, let's say the count of pods was like 50 or 100, you know, pausing it makes a lot more sense, especially if maybe we start it and then all of a sudden our alerts and alarms are going off because we might be having some trouble or some users are reporting issues and, you know, let's put the brakes on here, right? So we can go ahead and resume this thing, and we're going to do the same thing now. We're here. Actually, we can do, let's roll out history, deployment, go web app. I think this should get it for us. There we go. So we have, this is a second revision history of this. Okay, let's go ahead and and resume this thing. And so now we're going to see the stuff happen, right? I might not be fast enough here. So the old ones are going away, right? And then we're just left with the two newer ones. Okay. So we verified it's complete. We're all good. And let's go see if we actually go and go to this URL. Notice it does say the word improved. Okay. Awesome. All right. Now that helped us play with rolling it out a new version and managing it, but it gets fun when we do these Canary deployments and such, and to start to see what's happening behind the scenes. Okay. So what we're going to do, we're going to go back to put V1 back out there, right? Right. We're going to go back to that, and the ID should actually match. We're going back to the old replica set. So if I actually go back to here and I refresh, notice we're now the improved word went away because all of our pods that are running are the V1, the old replica set. Okay. Now what we're going to do, we are going to make this Canary deployment. Okay. We're going to get this thing. Oops, sorry, I forget that that's not there here. That should, oh, sorry. There we go. There we are. Okay. All right. So notice, right, we're using this, it's basically the Canary deployment. We're going to make a second deployment, right? And we're going to go ahead and modify this to stick our registry name in there, because our registry is unique per lab session you have. All right, so now if we put this canary out there, notice the replica counts 1, right? Okay, let's get the pods. Oops. There we go. And please ask questions. If you want me to dig deeper into something or explore more, please, by all means, put it in the chat or whatever. Okay, so once again, notice that here's our canary, all right? And so if we actually go here to the service endpoint, what we're gonna see is every once in a while, I'm gonna hit the canary one, right? Notice how the word improved pops in there. I got 2 of the old and 1 of the new, so we're round robining across it. We can also sort of see this to help us. We can make a pod that has curl in it, and it's in the name in the area here, so we can look at it, right? So let's go ahead and do this. Okay. All right. So let's run that pod and let's get inside it. Okay. So, right, we're inside of a running pod, right? If I exit out of here, and it's in the same namespace, so that allows me some privs to do things, right? So let's go back into it. Okay. So what we're going to do here is we are going to curl the Go web app, and we're going to do it a bunch of times, in this case, 10. And we're going to look for that specific HTML line that we changed. And this just makes it so, you know, we get something a little bit more concrete as opposed to sort of having to rely on hitting that refresh button every time. And, you know, I like making little samples like this, you know, this here, when I made this lab and this part of it, this was, to me, it was a way, how can I do this without like the randomness of the web browser and pressing buttons and stuff? And, you know, as you learn Kubernetes and as you learn all different frameworks or technologies in general, I always encourage people to do your own things like this to help you as you learn or as you test stuff. All right, so this confirms what we saw when I did it manually in the web browser. Okay, so now that we know this, and once again, depending upon how we done this, the browser may have cached stuff. When I use the curl, I sort of, you know, like I avoid all of that stuff. Okay, so now what we're going to do is we are going to actually add a service for the canary, right? So the current service I'm hitting up here is going across all of the pods, regardless of the version. Well, what if I just wanted to test only the canary, right? So this is where we're going to now, whoops, sorry. Let's do this again here. Let's get out of here and we're gonna curl that. Okay. All right. And so now we're going to make a second service, just like we have a second deployment. And this one is going to have a label. We're going to make this service. So it also requires a pod to have a label of track canary on it, which should match our deployment, which has that third label. Okay. Let's go ahead and apply that thing. Okay. All right, so now what we're going to see, we'll have the extra service in there, right? And we can also, okay, right. We'll be able to access it as well if we were to expose it and write ingress for it and so on and so forth. We aren't doing it in this scenario. So if I describe that service, all right, so what we see, yes, we have our endpoint. We got an active one. It should be healthy. All right, let's go back into our, basically into our curl pod. And let's go ahead and do the same thing again, but the service name is going to be Canary. And if we hit it 10 times, because we're hitting only that pod, right? If I switch this line and I go back to Go Web App, which was the main one, I'm going to go across the 3 pods. So this is sort of simulate how we would do this if we wanted to, actually do the Canary deployment. And once again, small numbers are tough here, but the reality is, imagine we had 50 pods, right? And we're introducing, we want to put one out there and see how it's going, right? Okay. And it allows us to specifically hit it, etc. Okay. Questions on this and why we did it, or sort of the testing, anything like that? Okay. So the next thing is, right, we let's say it's successful, we want to move forward with. So to actually do the deployment, we go to the Go Web App deployment, right? And we're going to change the image field to be the 1.1. Okay. And then we're going to change our Canary, oops, typo, to be replica count of 1. Or sorry, 0. There we go. All right. So what we can do is we can just go ahead and apply the directory. Some of the stuff won't change, but we can see the 2 configured that I changed. And after it's done, as you can, the output we hopefully should see here, we're going to see the 3 deployments. We're all up on the new version, on the regular one, and the Canary's back down to 0. And we can leave it sit there until we're ready to use the Canary again. There we go. I know the wrapping sucks here with the long registry names, but you can see the Canary here is at 0, and we have 2 of the front end. Okay. So now if we were to put everything back, basically like, hey, we did this for experimentation purposes. We're going to revert our back to the V1. We're going to delete our curl pod and sort of put things back to the way they were before. Once again, we can throw it away, or we can actually run all these commands to help us. So that's the Canary and sort of managing deployments. Any questions on that? Okay, got a lab here. Bootstrap this one in case there's any questions that come up. Let's go back to here we were. Hey, there we are. We're back to everything as we wanted it. Curl pod's gone. Oh, I didn't delete that one yet. There we go. This should hopefully be okay over here. You might be wondering why is it hanging here? Over time, the Kubernetes team has changed the behavior of kubectl. When you apply files, typically it just applies them and goes away. So it's asynchronous. It doesn't wait for anything to be completed. It was determined for scripting purposes and other things that when you're doing removal operations like this and some other things, it will actually block and it will wait. Because if you think about this, they're in that scenario as the apply, right, was a different way to do it. When I'm issuing that delete, I'm scripting. If it just came back to me, I may have to wait before I do my next steps. And so then you get into the scripters have to write, a loop, and you got to check stuff, and it's just not friendly. So this is the behavior and why it showed up differently like that, in case you ever wondered that. I'm going to leave this sit over here just in case questions come up and anybody wants to return to it. And I'm back now. I'm into the lab 5, which is the second lab in this part 2 within the learning path. Okay. So let's move this up here and let's take a look. Okay. So let's make sure that we got everything running on this lab. Wonderful. It's nice when things work, right? Okay. Now, that was a way we said, typically after you deploy an application, you're eventually going to get updated. And so how do you update it, seeing the behavior of it, experimenting with the pausing, different deployment strategies, and so on and so forth. The next step that we go into is, well, every application is a little different. And the more that we can tell Kubernetes about our application, the better, right? In this scenario, we have two deployments, one of the Go web app and one of the database. Now, Kubernetes doesn't know that one of them is a database and one of them is a web app. It doesn't know that the web front end requires less memory and less resources than the database, which needs more memory and typically more resources. It doesn't know that. It doesn't know about any of that sort of describing, what this application is like versus another one. So we need to give it hints and help out with this. And the resource requests and so forth are part of that, right? We're going to tell Kubernetes, if you recall, we're going to take, hey, we estimate that this application needs at least this much. And so we're going to basically, the more information and metadata that we can give to Kubernetes, the better job that it can do of managing my cluster, my resources, so on and so forth. So let's go ahead and start this. All right, we bootstrapped. All right, so let's go ahead and we are going to modify it to add in the resource requests. All right, and that's what we're being asked to do. So let's go ahead and go. We got to get to it. Go web app, and we're going to do it for the web front end here. Okay. Okay. Now it wants us to add in these to it. Doesn't tell us how. So if we go back to here, let's do a resource request and let's see if we can find some examples in here. Okay, this is helpful. So, like most of the stuff, it looks like the resources is a sibling of image. That's usually how I like, when I look at what I need to do, I look at where the alignment is. So the word resources is just at the same level as image. It's a sibling of it. Okay. So it's per container within a pod. So I'm just going to copy this requests part because that's the only part we're doing right now. Let's go ahead and use it over here. Okay. So sibling of image. Okay. I need to bump this over. That's a sibling of image. That was indented, and then that was indented, right? And my values I'm supposed to use are 256 of memory and 200 milli-CPU, quarter of a CPU. Okay, let's see if I did it right. Let's go ahead and apply it. Nope, I didn't. Look, I got JSON problems. What did I mess up? Oh, look at that. Oops, there we go. Something wasn't lined up. Doesn't matter how long you do this, mistakes still happen. All right, so let's see. Is it changing things out? Yeah, okay, we're moving, right? We're got rid of the old ones and we got some new pods. See, the age is different here. Okay, great. And let's describe it. And what we should see in here, notice right here. Okay, it took what we wanted and put it on there. Okay, great. And so, like I say, the good part of this is that if Kubernetes did not have an available node in the cluster, and that node did not have at least this much free resources on it, the pod wouldn't go there. Because if it did put it there and there wasn't enough of that, I know this is a small number, then it would fail to start up. Think of like a very large application, right? Or something, very large database, maybe a heavy Java app or something like that. we don't want it to Kubernetes to put that onto that node, start it up, and then the thing crashes because it goes to try to get enough free memory, or the queries on the database are taking too long and timing out because there's not enough CPU to perform the queries in a reasonable amount of time. Okay. So that was the lower part. And then we're going to add in the upper part, like to prevent bugs or runaway apps, right? This is optional, but it's good to have it. And this is where we want the upper limit. So we're going to say this was the requests, right? So we're going to add in, this is limits. And we'll put memory. It wants us to put it at 512. And CPU at 500 millicpu. And the idea here, right? Every app is different, right? I can't tell you what values to use here. People sometimes ask me, they used to say, Ryan, well, what value should I put there? And I'd look and say, well, what values do you have for that today, wherever you're running your application, right? Do you have an alert or a monitor set up that says, if it uses more than this, it's a problem? Or do you have limits set on the virtual machine it's running on, and so on and so forth? And unfortunately, what happens is a lot of times people look at me and they're like, well, we don't know what that is today. Well, determining these values is not an exercise with Kubernetes. It's an exercise of benchmarking your application, which typically has nothing to do with Kubernetes. So if you've done this homework before, outside of Kubernetes, wherever you're running your apps, it's literally just plopping the values in to your YAML definitions. Excuse me. If you haven't done that work, then basically you have to make a decision. You need to invest some cycles to properly benchmark it, etc. And that's what we see. A lot of times we get in these things and they're best practices, and people sort of hit them as they're doing Kubernetes work, right? And so that's why a lot of times people feel overwhelmed as they migrate applications, because Kubernetes is enforcing that you do these best practice things. And a lot of us haven't been doing them, not necessarily because we didn't want to, but because of time and other things. So, okay. Questions here before I move on. I'll go and apply this thing. Come on, you can type, Ryan. Okay. Well, and if we describe again, notice we see it got in there. Okay. All right. Questions? Okay. We're about halfway through. I think let's see, I remember what else is in here. Yeah, I think let's do the probe one. And we'll play around with this. And I think that probably will be good, but we'll see where we land. Okay. So just like we can tell Kubernetes information that like the database needs more resources than the web app and so on and so forth. Well, Kubernetes, if we don't provide any other information, how does it know if the running application is healthy? Right? Pretty much all it can do, unless we give it different information, the only thing it can do is say, is the container up and running, or has it crashed or stopped in the Docker world or container world by the runtime? And so if we don't have that information, or that's okay, it's still better than nothing, but that really doesn't tell us, right? I can have an application that's up and running, but maybe it's missing some configuration files, and the thing's throwing bad HTML out, or it's throwing 500 return codes and things like this. So, this is another thing of like, specific to your application. And so you have these health checks and monitors set up in your infrastructure today. And pretty much all we do is we map them over into the Kubernetes world, into the YAML world. This, once again, is another scenario. As somebody asked me, well, like, what should a probe be? What should a liveness probe be? What should a readiness probe be? Well, what are the ones you have today? We're just going to map them in. And if you don't have them, it's another exercise of doing this for your application. And I always suggest to people, perform that exercise, do it, and make sure it all behaves the way you want it to outside Kubernetes before you bring it into Kubernetes. You don't have to, but it's a nice, less variables at one time. All right, so the liveness is it alive, right? So the liveness that we chose to do here is that we're going to check on something and to try to make it determined to see, you know, to help us think about how this does and experiment with it. Let's do an example that's not with the Go Web app, right? So this, we're going to deploy just a pod, and it just basically, what does it do? It opens up a terminal, and it is going to basically sleep forever. So it's going to stay running, and it puts a file in the temp directory that says healthy. Okay. And what this will allow us to do is we can set up a liveness probe against that and check it to see whether that file is there or whether it says healthy or doesn't say healthy, etc. So let's go ahead and get this thing. Oops, there we go. There we go. Okay. All right. So I'm going to go ahead and apply it. And we should see it running here in a second. Okay. If we look, there it is. Okay, that's good. Now let's see. So what we're going to see is on this also, when we look at it, and I'll look at it in the, right? We describe the liveness probe to say Kubernetes basically every 5 seconds is executing the cat command inside the running container and seeing and catting that healthy file. And so far, it's coming back successful, right? So if we describe it again and we look at, right, we're going to see that everything's okay. Now, we're going to actually pretend the application has gone bad, right? And so what we're going to do is we're going to remove that file from the running app. Okay. Now we're going to wait a bit of time, and then we are going to at least 5 seconds because that probe's got to fire. And then we're going to look at it. Notice here in the events, I have a warning, not an error. The reason unhealthy, it's happened 2 times so far where the kubelet has tried to exec. It runs the cat command. Cat can't find the file and throws a non-zero return code, hence failing the liveness probe. Okay. All right. Okay. That liveness probe also has to fail a number of times, right? Now, so we're going to see it. If we do it again, it's going to notice it has happened now. Where's it at? Liveness probe warning failed. It has failed now 43 times over 57 seconds, right? Now, and if we look here, there we go. Okay. Notice that as we keep, sorry. Notice the restarts is 1 on this. If we sit here and wait long enough, we're going to see it flip to 2 and to 3, etc. As it says, hey, it's not alive. and then tries to restart it. That's definition of liveness probe. The same example we can do with the readiness. Now the readiness is going to have a different effect, right? And I can actually just, I was going to manipulate the files, but it's okay. I'll just, okay. All right. So the readiness, notice we're now running. Everything's good. If we look at the readiness test, we're doing the same thing. We're just looking at this file, whether it says healthy or not on it, okay? Now, if we do the same thing we did before, okay, and we can put a web front end on it here. All right. We describe the readiness. Oops. Sorry about that, folks. We are healthy, right? It's working okay. Our IP address is up there. Okay. Now, we're going to do the same thing we did before. We're going to get rid of that healthy file. Wait 5 seconds. And then let's look at the pod. When the liveness probe failed, Kubernetes restarted it. When the readiness probe fails, as you can see there, it failed, same thing as before. It doesn't restart it. Instead, notice restarts as 0, but 0 out of 1 is ready. If you recall, a service round robins traffic across the pods with matching labels. What it does is it takes it out of service. So the application's still running, but Kubernetes is not going to route traffic to it. Once again, we have small numbers here, but imagine if this was 50 pods and one of them became unhealthy, we want that one to drop out. Now it's still running. I can go look at the logs of it, etc., but it's not going to accept traffic from the web requests, right? Notice there's no endpoints listed because, well, we only have one pod and we took that pod out of service. If we were to put it back into service, for example, let's go back to our here. If we, right, we're going to see it, the readiness start to happen here. And if we go look at the endpoints, we're going to see the IP address of that pod come back in. It would be receiving traffic. Once again, this is one of those scenarios where, you know, the more information we can supply the Kubernetes, the better job it's going to do when these edge cases happen. It does a pretty good job out of the box, but the more we can do, the better. So in the Go Web App MySQL case, you know what we're going to do? We're going to go and we're going to actually first say that in order for it to be alive, it has to be port 3306 has to be opening and accepting connections. Additionally, for it to be ready, we're going to execute a SQL query against the database on a specific database and table in there and make sure it's actually got our schema, got entries in it, etc. That's a much better check than Kubernetes just saying, is the container running? MySQL may be running, but the queries may not be executing. The schema may be wrong. The data may not be there, you know, a bunch of things. And so by doing this, and hopefully these are things you have running today, and we just map them over into the whole YAML definition in Kubernetes. I can continue with some of this, but I'm going to pause here for now and see if there's any questions on what I did. like I say, what readiness probe you use and what liveness probe you use hopefully can just map over from whatever you're doing today outside of Kubernetes. A lot of times people call them smoke tests, or what monitors and maybe Nagios and other kind of like probes you have going from other typical administrator tools, where you basically take those, bring them out of those tools, and they get put into the YAMLs in here. I will also tell you that this is a little bit of a difference here between maybe what you did before in IT and then with Kubernetes, right? A lot of times those monitors and alerts that we're talking about that were set up, they weren't set up by the engineering team, the developer team, right? They might have helped determine what the probes and monitors and such are, but then they were configured, set up, etc., by the administrators. And so then things slow down because you have this handoff, and was it done right or was it not? And applications change, and the definition of what your probes are and what they do may change over time as well. Then you got to coordinate that. Here, the control and the definition of recording this is in the hands of the people who need it, right? The development team that is authoring the application, if they need to update what query it is or so on and so forth, well, they just update the YAML definitions in the next version of that application. When it goes out, the probe is updated as well. Everybody's happy. And the administrator side of things, the operators, they can say, well, I don't have to worry about handling all of that manual stuff. I'm going to focus on what probes are failing in the cluster. And, do I have more than one? Do I have and I can set them up generic and not worry about the logic. I can just look at my entire cluster and say, how many pods do I have that are failing because of, or that are not ready or restarting because of failed probes, and make sure I have an overall health. And so that's another nice separation I really like, with Kubernetes, is that the control is documented in source control. It's within the hands of the teams who actually know what to write for these as well. Okay. Let me pause here again for some questions. I'll check the chat. I know we are over lunchtime for some folks probably, or maybe since it's so hot everywhere, everybody's wanting to take an afternoon siesta or something. So I can definitely understand that. I'll probably go for a quick walk in the heat, but carry a water bottle after we're done here. There's a lot more to this lab. Any of you guys can go launch it, play with the stuff, etc. I encourage you to do that. It's a fun one. There's a lot here. And then also, just as a reminder, if we go back, right? We go back to the one more to the learning path here. Right. Here we are, core concepts. Last month we did part 1. This we did part 2, and we're going to continue with these. So if you want to able to attend next month, this part 3 is what we'll be going over, and where we're going to, in the journey of things, right? We're going to dig more into like how we do networking and how we're going to organize things with all the labels and across clusters and nodes and so on and so forth. So that'll be the next time. Feel free to use this at will. If you go through all of these, once again, there's a ratio of lab to exercises, and then it's all free. All you have to do is have the just sign up with an account and go through it. I'm not doing too good. I only completed 19% of this. July 14th. That's the date. Yeah. And if any of your colleagues or coworkers or friends that might find this useful, either the stuff, please send them the link to the learning path. I'll put it in the chat so we have it here. There we go. And then also, as AJ mentioned, we'll have it's been recorded and we'll have that go out public so that you can send that around too if you'd like. All right, let me go back to here. I want to just, I think the last thing, while in case there's other questions coming in, I want to show like the actual examples we chose because it's fun to talk about those. I won't do them. I'll let you guys do those if you want. But if we go back, so I said, hey, for the database, we're going to say check to make sure TCP port 3306 is going and then execute a query, right? Okay, so basically if it failed to open the port, then we consider it not alive. If the port's open, but the queries aren't working, well, then the application's alive, but it's misconfigured essentially. When we go to the web front end, all right, we decided to do, basically we say, hey, think about the things you might want to do. And what we come up with, we said, well, the pod runs on port 8080 and a web server. So let's go ahead and make sure that port 8080 is open and listening for a connection. Then, well, it could be doing that, but it could be spitting back the wrong HTML. Heck, we could have maybe deployed the wrong website. So we want to make sure it comes back with the correct web content. We want to make sure that we hit a page where the application needs to contact the database, like reading something from it. But we could even have a problem where maybe it's configured to use the login account against the database that doesn't have write privileges, right? And so once again, these are the things that hopefully you're testing and doing today in your application, and we just map them into Kubernetes. And so we have this, if we go down to solutions, we can take a look at a little peek at it. And if we go down to the probes on the Go web app, you'll see some of the stuff we did in here, like adding in an HTTP GET on 8080 to make sure it returned and so on and so forth. And so these are the kinds of things I encourage you, to think about. And if you have folks or friends who tell you about going to Kubernetes, what do you need? These aren't required, but the more you can put in here, the more resilient your application will be, especially as pods come and go and move around the cluster. So, all righty. That was the stuff I wanted to cover and share with you all. I hope it was helpful. As you can see, getting in and sort of a combination, actually using your application and then contrived examples as well, to me, I know for me personally, and hopefully you guys too, really helps you understand what's going on. All right. Well, AJ, I think I got to the end of everything here that I wanted to cover. Thanks for those who are stuck around. I know schedules are always tough, especially in the middle of the day, middle of the week, etc. So I appreciate it. And we'll see you again next time. So.
Yes, thank you, Ryan, for today's presentation, for walking us through part 2. Looking forward to seeing folks for part 3. We'll be sending out the registration page shortly. And as Ryan mentioned, and as we mentioned earlier, this has been recorded and will be available on demand shortly after the end of this presentation. So feel free to watch this again or share this out with any of your team members, as well as the link to go through the learning paths on your own as well. So we look forward to seeing you guys at our future events. Have a great rest of the week. Thanks, Ryan.
All right. Thank you, everyone. Stay cool out there.